Hello, everyone. All right, good. I'm surprised you are still energized after the food, but great. Modularization has been a big subject for the last few years, especially in Android community, right? So I'm going to talk about how to keep this under control, how to make it still structured, even though you're adding more and more modules. I'm Yahya Bayramoglu, working at Uber. So if you want to experience how it feels like working in an environment with multiple modules, thousands, we are hiring. So come find me afterwards. Let's talk. Or let's talk with modularization or any other subjects that you want to. All right, moving on with structure. First of all, who thinks of modularization, when I say modularization, about kind of this, right? You have an application, you have features, and features has sub-features, sub-features has some common shared code, and so on and so on. So you have multiple modules, they're depending on each other. Don't laugh, this is a good example. But who knows this actually can end up by this? So this is what we want to avoid. Like, we want to keep it this way, right? So let's first analyze what we see here. We have an application, and we have the features, we have sub-features, we have some shared code, right? But there is somehow a structure. There's an invisible layers here, right? So this is the first thing to notice, that if we think about this somewhat tree, software tree, not the regular tree, they have already like levels, right? And then if you look at it, there is one special thing as well, that neither of the modules in the same layer depend on each other. This is an important thing to notice as well, and keep it if it's possible. I'm going to tell it later on more about it. Also, here it will give you more things to think about it while you're developing. Is the API clear enough? Is it constrained enough? Is it like self-contained, or so on? But then, once you start doing it, you're going to feel like this cute guy here that trying to reach out something on the other module, but it just can't work, right? So let's see how this modularized structure can actually be beneficial and not just a pain. First of all, we need to come up with some rules to keep this structure under control, right? So first thing that we said, feature-based modules. There are already a few talks that what is the benefits and so on. I'm going to also explain a little bit. The second one that we talked about, horizontal layers, and the third one is the features cannot depend on each other in the same layer. But how about how to create these horizontal layers, right? How the features cannot depend on each other. How about sharing some code between features? How about the common features that are depending on the other multiple features? How about navigating without depending on that module that you want to go, right? So many questions. I'm going to try to explain as much as possible, but you will have this kind of questions coming up while you're even working on modularization and building more modules and more modules. But then it's how software, right? You get the problem, you solve it, you move on. OK, so why feature-based modules? First of all, that they keep the integrity of the code, right? You have a feature, and here is your module for it. Features doesn't necessarily mean screen, or feature doesn't necessarily mean view or whatsoever. You can define your scope of the feature, what it is. It is easy to follow dependencies. You get the feature, you follow up all the dependencies that it depends, and then you know what that feature needs to be able to compile or build or whatsoever. It's easy to extract and expose, as I mentioned, because you can follow the dependencies and extract it directly. And it is somewhat requirement or works well with dynamic features, right? Because they need to be self-contained features to be able to dynamically delivered. And horizontal layers, it creates a top-to-bottom dependency only, so it's kind of a unidirectional, right? this will allow us to make sure that the layers has one directional dependency. So if you're on the top level, you can depend on the one in the lower level, but not the opposite, to avoid any kind of circular weird stuff. So let's think about layers. Basic examples. This is completely as an example. You can use your own layers depending on however you want to shape them. Let's think about a core, which might contain architecture, networking, logging, etc. And then you might have a testing layer on top of the core to make sure that you provide testing infrastructure for the models in the core models layer. And then you might have the features layer on top so that you build your features. It can be anything potentially can live by its own. It can be a profile, like a message or feed or anything else that your application has. And the third rule that we talked about, that features cannot depend each other. So this will create the vertical independency. It's going to be the key to extract it. Otherwise, the moment you start pulling one feature, all the features will come along if they depend each other in the same time. It was a dynamic feature requirement. I'm not sure if it's still the case because it keeps improving. But in the beginning, with instant app, dynamic features was a requirement that that one cannot depend on other ones. OK, I've said a lot of things, but how does this actually look like? So this was the graph, the diagram that I showed. And if we think about it, let's assume I want to build my application, but I want to build in a way that I don't have to build everything, but I just want to focus on one feature. Can I do this? With this diagram, yes, because I can actually exclude everything else because nothing depends on each other here. Or I can do this, or I can do that. So by modularizing in this structure, you can actually make sure that you can build specific features only in the application. But how about the sharing code, features between features, right? Let's also go into details here. So let's say every layer can have a common package. Or let's say this common package can contain features or sub-features. And features can be moved to this common package if they needs to be reused, right? So the goal here is not put everything into common features so that everything depends on each other. That's not how, that's just work around on the layering. But to keep common feature as less as possible so that you share only the code that you need to share. Looking at the diagram again, so this was our layer, right? Feature 1 to 3 is in the same layer, and then they want to share some code. So what you do is basically create a common. They are still in the same layer, in big layer, but then you have some sub-common layer that they can be shared. Again, it is up to you to decide, in this case, if the models in the common can depend on each other or not. I'm going to show it later on. So we end up with this, right? We have a core layer, we have a common, model A, B, and then we have the core C, D, and then features, commons, and so on. So if you look at from here, features are a top level of the core layer, right? So every module in the features that can depend on the core. But nothing from core can depend on features. So this is one of the things that is important. And you can think about like model G can depend on E or F, but not on H, right? Because they're in the same layer, but they can depend on the common. They can depend on everything that's in the core. So if you go one by one on all of this, it will kind of end up with this diagram, this table. How to read this table? You pick one of the left ones, and then you say, is it visible? Model H, can it depend on model D, for example? It's yes, the otherwise it's no, and so on. So if you look at here, you see this part. They are kind of mixed. Otherwise, it would be stepped through dependable or not dependable ones. The reason they are mixed because those are the common modules. So you can decide if you want to be even stricter on the making sure that even the modules in the common cannot depend on each other or not. If you say they shouldn't depend, then it's going to be read completely. But the idea here is to make flexible for at least for those cases because it's a reality, right? Well, should we do this manually? Like it can start as a convention. Yes, you can say on the code reviews or whatsoever, hey, you should not depend on this module and so on. But this can be also automated, right? I'm not going to show the code, but you can just write a simple Gradle task to make sure that dependencies are defined in the accessible package for the modules that they are depending each other. But what about data domain presentation, right? Okay, so first of all, for the people who don't know about this concept, I'm going to explain what is data. It's the models, network API, or database API, or whatever basically is data. Domain is your API integration, business logic requirements, or use cases, interactors, executors, whatever kind of patterns that you're using to define that your domain business logic. And in the presentation that you have all the activity fragment view presenting, rendering, or whatever. So why not use this as layers? Okay. Well, it is also a common practice, although it does not actually provide a scalable or flexible structure. And it kind of breaks the integrity of the code, of the feature, because if you have, for example, one feature and it has data domain presentation layers, of course, then you want to take that feature out, then you need to go actually pick these 3 pieces from different modules or layers, or hopefully that you also go module further. But then it's more complicated to take the feature out or in that case. It complicates finding the feature and the dependencies. But what you can do is you can still keep the feature-based modules, but then have the data domain presentation as on top. So we had this kind of tree, right? We had the core common modules, and then you can actually have inside those modules data domain presentations as a separate modules as well, if you want. All right, just structure is actually not enough. In order to make sure that your modularization can scalable, you have to also modularize your build script. I'm going to talk about Gradle, but the things that I'm going to talk about can be applicable for Bug and Bazel as well. So first of all, referencing. Use the build source for defining const, because build source is the first part that will start actually compiling. And if you have your definitions in build source, if you're using Kotlin, it's nicer. Anyway, so you can define your dependencies, plugins, scripts, or modules as a reference so that you can reuse those constants, right? And then this would make every module has the reference instead of the hard-coded string, instead of finding all those strings around and replacing later on. That's going to make it easy to change from one place because you have it referenced. It doesn't matter the content, you can change the content later on. Before we go there, the benefit of this, because I just mentioned about the structure, how you would move the modules into common if they need to be reused and so on. So this means that you would actually need to move some modules around at some point, the more modularized that you go. By doing that, what you would need to go, find and replace every place that modules is actually dependent on, right? But instead, if you're referencing, you can just change from the source wherever it's used. So this would look like this. So you have the plugins, like Android application. You have the scripts, like you get the script path, and then you define all your separate paths. And then you can also apply the same thing for modules. You can even create some functions to help you here to say, okay, if it is core, here is the all prefix package, and then you can just pass the naming of the module to the required function to get generated paths. Please have a convention for the model names. That is like literally crucial. Not at the beginning maybe, but at the end then you start having like all these different type of camel case, kebab case, snake case, and so on. So just decide one of them and stick with it. So we talked about referencing, but we need things to reference as well, right? So you have all the scripts, tasks, and so on that are defined on your Gradle configuration. You can also modularize those, which can be like an Android, that you have this Android block and minimum SDK, and then you have your source configurations, etc., etc. So you can extract that as a separate script. You can have lint as a separate, and detect, and find bugs, or whatsoever, right? And then you can compose your scripts into one single one, which is Android module, let's say. And then you can make sure that whoever uses Android module comes up with all this scripting, tooling, etc. Well, you can also have Android Java module if you still have Java modules, and you can just attach them as well, because Kotlin is by default, right? So this would look like this, the Android modules Gradle. You have the plugin, which is an Android library plugin, and then you have the scripts, configuration, lint, find bugs, check style, and so on. And then you have the Kotlin Android. And you have the documentation. Please have documentations. It gets even actually trickier when you have modules with no documentation. Maybe you can even include some README on the module. That would be great. All right, so applying all these changes that having the references, modularized scripts, and so on, that you would ideally have a Gradle build script for every and each module looking like this. Simple. You have a script that applies Android module, and you have dependencies. That's it. Well, since Gradle actually works from upper level to detail project, you can always, of course, override any configuration you want here. But for the simplest model, you would have this. It's basically just a recipe of how to build that model. If I want to build this model, I need this dependencies. That's it. All the other configurations are defined. Moving on, navigation. That is for the modularized structure applications is one of the biggest problems, because we have quite an interesting navigation structure in Android. And so everyone starts figuring out different approaches and so on. And there's this recommendation. So I'm going to let you look at it a little bit more. So please don't do this. Please don't use fully qualified name to go to a single activity. First of all, let's assume you want to go from module A to module B. This is way too much information for module A to know about what is in module B and exactly where it is. And if you're using like this, I especially in a purpose put the package name as a variable. What if I move the class? Yeah, of course, for refactoring, it's going to work in IDE. But for this case, it's going to say, hey, there is a strings that I can refactor. Do you want me to refactor? Let's say you forgot to tick that. It's not going to refactor here. It's going to start crashing somewhere else. And let's assume you're using Buck or whatsoever to only the project for the apps that you're working on, so that you don't index all the others. And then this will not be changed and so on. So this is way more problematic than it actually looks as innocent as is. So there was a tweet from Gabriel saying that how do you handle navigation for multiple modularized applications, right? And I was really surprised going through that thread, seeing everyone is inventing different approaches. And I was like, okay, am I the only one who really thinks that the deep links are the kind of a silver bullet here? it was there forever, right? I'm not. So there is a talk. It's called Navigation in Modular Application with Deep Linking by Damien Burke. You can find the link here or online. He goes through different type of navigation handling with deep link. I say different navigation because it can be public content indexing, it can be different modules, it can be that there's new navigation components. So in his talk, he goes through different kind of steps. The moment that I tweeted that, I started to get more questions, and it became a Q&A. So the interesting questions were, how do you handle args, especially the ones that do not tokenize to string or query parameters? How do you check if a model has been installed with dynamic feature models? How do you handle transition elements, right? How do you handle the activity results? Or how about type safety? Deep links are only destinations. What you launch is still an intent, right? You say intent, view, and this is the deep link string that you want to go. You can still attach all the activity options that the transition element requires. You can still attach the call start activity result instead of start activity. You can still attach any additional data you want to. That is just how you handle deep link. It's not that deep links doesn't support. And for the last one about the type safety, just thought for consideration. That's not I'm recommending or anything. It's just a single idea that I could think of. You can use the string format for deep link with query parameters. And you can enable link checks that is already in IDE for formatting. You can say there's two of them, string format invalid and matches, which will verify the amount of parameter that you pass and the type of the parameters that you pass that matches in the string. So if you have this, for example, predefined string, and you see this is string and this is an integer, it's not the best, but it works. And you call it this way. If the content ID is not string, it will lint. You can just convert this to error, so you basically make sure that it's not, and so on. Anyway, moving on. How about multiple activities? How about single activities, right? Activities versus fragments versus views. Frankly, deep links do not care, right? As long as you map their destination. For multiple activities in an application that is already handled by the framework, you just in the manifest define this activity has this deep link. The framework will make sure that whenever that deep link is launched, your activity is going to be open. You can also make sure that not every activity is public, but you can still use an internal schema that is not public, and then you can set an exported false to make sure that no one else can reach to that activity outside of your application. But for the single activity applications, which is kind of getting popular, that requires you to implement that mapping, right? But how would you implement that? I'm going to just go over quickly and simply. So like if we think just random things that's step by step, you would have the navigation module, right, in the core layer, as I defined, and have the functionalities so that it knows what to do there. And then you would have every feature defining their own deep link parser, resolver, handler, whatever you want to call them. And an application basically just gets the instance, binds the resolver, and then basically provides an all together. And whenever you need to launch a deep link, you just use that one. And then say, hey, go to there. I don't care in which model it is. I don't care in which location that is, and so on. How would it look like? So the basic example, let's assume this is a deep link resolver. It has two simple functions saying that, can you resolve this? And if yes, resolve it. And if you see here, I just return a navigation rule. It's just a made-up name. You can have your own implementation, and this is just to make sure that I know how to handle this thing, right? And then you would have the list of resolvers and iterate on it, say that, hey, can you handle this? Yes, OK. Then handle it, resolve it, and then navigate to that one, right? Super simple code. But the complication comes here. How do you navigate, right? Depending on your navigation rule, as an example to answer the questions here, for example, if your navigation rule has a result code, then you run start activity for result instead of start activity. Or you can handle your exceptions here, right? So you have a single point to handle all navigation errors. Or you can add any other thing here. For example, for dynamic feature modules, you can try to run it and then make sure if it's not working, or try to install it, or whatever your logic here is. How would it look like in our diagram? As I mentioned, you would have the navigation as in the core layer. The whole implementation I just showed would be here. And then you would have all your features providing different resolvers. So feature 1 would know how to handle its own resolver, its own deep link. And feature 2 its own, feature 3 its own. And the application would bind all this together. Well, by binding, I mean this, right? We are quite familiar with this pattern that you have an instance that knows how to manage all this stuff, and then you just append all the resolvers and so on, like interceptors in retrofit, or resolvers, or the converters, and so on. So the problem here, it needs to be done in one place and manually, because all these deep link resolvers will be provided from different modules, right? And if you're using Dagger, for example, you have to statically type your Dagger module on the component that can actually create this instance, right? And since every one of them are coming from different modules, if you statically type those modules into application, you basically break the integrity of that being able to extract the feature, because now application is kind of bind to that feature that you're trying to split it, right? Wouldn't it be great if you would be just able to do this? Because multi-binding is supported by Dagger, you can just provide all of them into a list and then retrieve it here and so on. Well, we do it for something, right? It's called Android contributor injector, contributes Android injector, whatever that annotation was it, in Dagger Android. The only reason it works because it's in Dagger. It is hard-coded with the fully qualified name, referencing that package, saying that if this is that annotation, do this. It is not a generic type. It is not open for anyone else to use it in their own way, let's say. But there has been a lot of issues in Dagger, people asking. There is a hope that one of the tickets were reopened, and they said, yeah, maybe we can actually think about this again. So maybe at some point we will have it, but until then, we need to do the left one, that manually, one by one, adding all these modules into one place. But hey, it's still something, right? And for summarize, have a structure defined. I think for whatever your structure is, just use this one or come up with your own, but make sure it's defined. It's written somewhere. If any newcomer to your company, you can just say, hey, look, this is how we structure our models. If you need to create a new model, follow this. If you are looking for a model, this can be a hint for you where you would find it. And modularize your build configuration as well, because modularization is not only for your features or Java or Kotlin code, but it's also about the entire app, right? So you can modularize everything. And show some love to deep links. They are not so evil. That's it. Thank you. Do I have any questions?
Hi. Do you use this modularization system with your RIPS architecture? So, and how do you combine deep links with attaching RIPS?
Yes, that's a disclaimer I forgot to mention at the beginning. This is not what we are doing in Uber. For the structure, we have a similar one. But for deep links, we don't use it for everything. We use deep links for only the public deep links. For internal navigation, we use the router from the RIPS. Yeah, that's basically applies.
Okay, basically, the question is, for example, you have some feature, and it needs to change the road screen that is the level above. So what router would you use to change the screen that is above the below feature?
Okay, if we are talking about specifically about RIPs, every RIP would define a listener to pass to the child RIP. So if child RIP needs to say something back, that is through the listener.
And if there are 3 levels below, for example, you have 3 levels below, and then you need to say something to the root.
Let's talk about it outside because it depends on your use case.
Okay.
We are using a lot of RX streams as well. If something that needs to be communicated between, it can be also depending on a stream, or it can be listeners all through it. But for further, let's talk outside if you want. Any more questions?
Hi. In your gradle example, I didn't see anything about constrain the visibility between models. Do you use this about constrain the visibility, ensure the independency between models?
Can you elaborate a bit?
For example, when right now we are using a clean architecture, and for example, my domain layer doesn't see the data layer and the presentation layer.
Okay.
I use the visibility. I constrain the visibility between these models. You don't use this to ensure the independencies between these modules.
In this example, no, I didn't mention. You can use that, yes, if it helps. Or, as I mentioned, you can write a script to make sure that the structure is aligned. So if you don't want to use, or if you didn't know about visibility, for example, you can just make sure that by the script, if someone adds the dependency, it still fails on CI. That,
Okay.
hey, you shouldn't use this dependency, kind of. But if it is possible to use visibility, yeah, go for it. We have a question here.
Yeah. Hi. Well, first of all, nice talk. I have a question because in the past we faced something similar to your proposal of the navigation component. But my question is, do you have a single navigation component for your whole application or a navigation component for every module?
Navigation in this example, as in the core layer, would be a single instance. So you would provide one navigation controller
For the whole application?
For the whole application, and then every module would define how they want to be navigated to themselves.
Okay, yeah, thank you.
Question there.
Thank you for the presentation. And I have a question about the deep link resolver. And so you check if the resolver can be resolved, then navigate to another feature. So
Yes.
let's say we have 2 features that can resolve the same deep link. What do you do?
First of all, you need to decide which one should, because it's not like so you can have 2 features that can resolve it, but they should have a priority over each other, right? So as a business logic, there should be something. If this presents, then use this one. If this not, then use this one. But in a modular structure, I'm trying to find the slides, sorry. In modular structure, it can be a little bit more difficult because you don't know actually which module is where, right? So if you have two deep links that can be two features that can handle the same deep link, then maybe you can think about providing one single resolver for those two to make sure that, and then inject that as a separate model to both. Am I clear? Okay, so what you can do, I don't want to even go through detail on this, but so you can have a resolver in a common model for those two features, right? And then they can expose themselves, or they can expose single instance of those resolver. And then in that resolver, you would decide, depending on your business logic, which one you should navigate. So that resolver would need to know about both features.
Okay. Yep. So do you have any other method to prevent this thing happen? So
Maybe more specific deep links,
yeah.
to not make sure that two features can resolve it.
Okay. And okay.
More questions?
Any more questions? Yes.
Yeah. How do you navigate to a feature that is a dynamic feature? It's not already exists in the application.
Mm-hmm. So this question actually came up previously as well when I give the talk. Because of the dynamic features are depending on public deep linking, when you deep link with the dynamic feature, you might actually check if the split install manager has an API that says, hey, this is actually a dynamic feature or not. And depending on that, in the navigation code that I showed, you can try first with the split manager, and if it fails, you can try to go navigate, or the opposite. So it's basically, you need a sign from the split manager that if it's actually a dynamic feature or not. Because otherwise, you wouldn't know also in general without even this system.
More?
Yeah. Hi. You placed the dependency injection model at the bottom of the tree.
Yes.
And you specifically mentioned Dagger. So which strategy do you follow to inject? Do you use components? For components, you have a main. How do you pass the dependencies from the application or between layers?
So I didn't actually, I have a few repositories on GitHub to play around with Dagger between models as well. What I could suggest, I have another talk for making features independent Dagger components than the application itself, so that you don't have to provide everything over top and so on. You can follow that approach, so that make sure that feature can live by its own. Or you can expose a module, Dagger module, from the module that you want, and then collect them on top parents that they are collecting.
That's what we do, but we have a huge application component referencing 20-25 models,
Yes.
and I can imagine the memory footprint is quite high.
Maybe, if we have this. No. Where is it? Oh, actually, next slide. This one. If you have a dynamic way of providing those, or if you're using Dagger 1, maybe someone still uses, you can actually make sure those modules are collected by some component without statically defining them. Right now, it's not possible, as I mentioned, but it's basically how the contributes Android injector works, right? You say, hey, contribute this to somewhere. It just collected.
We do use Dagger Android. Let's see what they come up with next.
Yeah. So
but still, the app component is a huge list of models.
Maybe, hopefully, in future. And check it out, the talk that I mentioned for splitting features for specifically their own app components. So I also explain how you can split the application component for specific feature based.
Thank you.
Any other questions? All right.
Any more? No? Thank you, Yahya.